Well, hopefully, folks, you watched the first video where we talked about classifying our polynomials. We are still in Chapter 8, Section 1. But what we're going to do now is the whole reason why we classify polynomials, why we make sure we put them in standard form, is so that they are in order when we are trying to do specific operations to them, whether we're going to add them, multiply them, subtract them. Later on in Algebra 2, you'll learn about dividing and all that good stuff. But let's take a look at these now as we sit here and we look at them. Okay, so our first example here, we have, and notice this is called the stacked method because we stack one polynomial directly on top of another polynomial. So here is one polynomial. Here's our first one is what sits on top. And our second one is what sits on the bottom. So our first polynomial is 3r plus 5. And then we are adding 7p plus 3 to it. This is just like from our chapter 1, guys. When we were learning to combine like terms, the only thing we can do when we are adding and subtracting polynomials is combine like terms. And again, we defined like terms as all of the variables and their powers have to be exactly the same in order to combine them together. So that's right. An x squared and an x, you cannot add those together. Those are different. They are totally different. So we have to be careful as we decide and we go through these and we decide what we can and what we can't put together. This is where it's a great idea to have a couple of maybe a few different colored markers or highlighters so that you can like highlight the pieces that have the exact same term. And then all you do is you add the ones that are the same color. It's a great idea to do that here. So take a look. Our first one here, we have what? A 3r. We have a 7p. Are those alike? No, of course not. R and p, there's nothing alike. And then we have some nice constants down here. These are alike. We can say 5 plus 3. We can actually add those. I have 8. And then there's nothing we can do with the rest of this. So I'm just going to go down here. I'm going to rewrite it. And I know someone is already noticing, well, which one do we put first, Mr. C? Use alphabetical order, guys. That's proper math. We like to keep things nice and order. Since P comes before R in the alphabet, I put P first. And that's it. You're done with that one. That one didn't even require a whole lot. This next one, maybe you're already noticing, hey, Mr. C, they're not stacked like before. But what's different about them? Notice that they put them this time in sets of parentheses. Because they're not stacked, if we didn't have the sets of parentheses, I wouldn't know where one polynomial started and the next one ended. So when they have them laying down, or like in this string style method, they will always wrap each polynomial in its own set of parentheses so that you can identify them. Here's the good part. When we have addition in the middle, it doesn't matter. We could actually, when we're just adding them, we could just get rid of all those parentheses, combine our like terms, and we're good to go. It's subtraction that we always have to have that mindful eye for, because that's the one that always tries to trick us. But addition, we are good to add this straight away. So let's look at our first polynomial. We have a t to the fourth minus 4t squared plus 9. All right, so I need to see things that I can combine with these on this side. Well, that's odd. What do I do here? This one has a t to the third. There's no t to the third here. This one has a t. I don't see any t's here. Again, this is the only way they can try and trick you on addition. Notice there are no like terms. There are no like. Oh, God, it looks like a kindergartner wrote this. Terms. That's what happens when you write with a mouse. There's no like terms. So all we have to do is just order them. And notice I'm putting them in standard form. I use that, I cross it off. Minus t to the third. Come up here, I cross it off. It's all about staying nice and organized. Minus 4t squared. Cross it off. Plus 3t. Cross it off, and then leaves me with my 9. Now, we have added it together. We've combined the like terms we could, but more importantly, we put this thing in standard form. So it goes from the largest exponent or largest degree of term down to the lowest degree of term. Look at this one. This one here can be a tricky one. Notice it looks very similar to this previous one, but this time, look, the dreaded subtraction sign. Now these parentheses they gave us are very, very super important. Remember, this subtraction sign is really like saying there is a hidden -1 here. And so we have to distribute this -1 to the first term. We have to distribute this -1 to the second term. We have to distribute this -1 to the third term. So basically, when you multiply by a -1, the sign changes on each individual piece. So the negative 5k becomes positive. The positive 3k squared becomes negative, and that negative 8k becomes a positive 8k. Well, what do we do with this piece? Just bring it down. Yeah, you're going to write a little bit. It's okay. It's better to write it down than to try to do everything from memory or try to like work off of separate lines and then you get confused. Now, all we have to do is combine our like terms. So I'm going to look at this one here. This is the largest degree. It's 3. Everything, there's a 1 degree, 2 degree, 1. So I have a -6 and a positive 5. -6 and positive 5. I owe somebody $6. I pay them back 5. I still owe them 1. You're having trouble with adding and subtracting negative numbers like most of my algebra students do, think of it as money. Money always helps us figure things out. All right, now we're looking for the next degree. I have a degree of 2, and that's the only one that's there, so bring it down. And I cross it off once I've dealt with it. Now I have a 3k and an 8k is an 11k. And I have added or subtracted these polynomials. Now, I'm going to be very, very cautious when you look at this next one. Okay, notice it looks stacked like the first one, but it looks different. Am I right? Mr. C said you didn't need to put these in parentheses because each line was its own, right? Look here, this little subtraction sign. If they give you a problem and it is subtraction, they are bound, they have to write this in a set of parentheses. You have to write it. If they give it to you, they have to give that to you like that because they can't trick you. They have to put it in a set of parentheses, which is giving out an indication you have to distribute this to each term. Now, you have to be careful because if you have to create this equation, you have to remember, and that equation is actually subtraction, you have to remember to put the set of parentheses in. They didn't give it to you. So now they're trying to, that's how they can try to trick you with these. But these sets of parentheses, I mean, they're doing their best not to trick you because they put it in a set of parentheses, which should indicate to you, hey, look at me, I'm parentheses, something has to go on here. Well, what is it? You have this negative that's being added over. So step number 1, this is what I like to do with these. Step number 1, distribute. So you get a negative 9p to the 4th. And this becomes a -5 or -5. Now, we take this and we bring it down here. So that would be step number 2 in solving one of these. Number 2, bring your top row down. Now, step number 3, combine your like terms. So a -5 and a +1 gives you a -4. And -9p to the 4th plus 3p gives you a -6p to the 4th. And you're done. These 3 steps save you. Take the time, rewrite it. Don't think you can do this all in your head. The last way they will confuse us on some of these guys, we have to be careful, is the word problems. The horrible, dreaded word problem. It's not so bad. Let's read it and see what's going on. This is the wallpaper border that runs all the way around the top of the room, is represented by this polynomial long. Okay, so the length all the way around the room is this. We have a room, 4 sides. The entire length all the way around is 5f squared plus 19f plus 11. All right, notice I'm drawing a picture, so I don't know what's going on here. Then it says 3 sides of the room have the following length of border. Well, we have one side is going to have a length of 6f. So I'm going to draw it over here on our side. The other length has 5f minus 7. And this side here has 2f squared plus 2. I can already see what they're going to ask me. What is the length of the 4th side? So what makes this problem hard, this is probably a level 4 or 5 problem if this was on an EOC test. Do we know what kind of problem we're even doing? Does it say use something from the past, maybe, that we have to think of, maybe from another class? What form of measurement do we have where when we add up the sides all the way around a rectangular object, we get a total amount? This would be a perimeter problem. Yeah, remember that? So we had to add all 4 sides, and then we have this one piece. So maybe you're thinking, oh, well, that's easier to find the piece, because if I knew 3 sides, I could add them together and I subtract from the total. Well, guys, that's exactly what we have to do. We have to take this, this again is this side work here, all 3 pieces. We also have what, 2f squared and a plus 2. And then we have, what was the 6f? So we have to take all 3 sides that we have and add them together. So this gives us a negative 5. 6 plus 5 is 11. And this just carries down. So when we add all 3 of these together, we have this total. So we said we had to subtract these 2 from each other, and then whatever's left over, that will clearly be our missing piece. Well, this is what's going to happen here, guys. If we just did this, right, and we put a minus, what did we really do? If we do this, we're only minusing this first term. That's why I said be careful. When they stack something, they're obligated to put it in a set of parentheses when they're subtracting. Well, if they are, so are we. Now that we put this in this set of parentheses, now we can see that we need to make sure that we go through here, right? And we say, oh, now I see what we're supposed to do. Now we can go through here and say, hey, I need to take this negative and distribute it to each piece. If you did not, or you forgot to put those sets of parentheses, you're going to forget to distribute it. So this becomes a negative 2f squared minus 11f plus 5. And just like we did before, I'm going to bring this whole top row down. Yes, I know it's trivial that I'm bringing it down, but trust me, you don't want to try to don't try to do the subtraction over a bunch of garbage work. You're going to make a mistake. Just move it down. Take that 2 seconds it takes to go ahead and rewrite it so that it is sitting here and it is perfect for you. Now we can go on to our step 3 and do this. So 11 plus 5 is 16. we have what? 19 minus 11 is an 8f. And positive 5 minus 2 is a 3f squared. And like that, this super complicated problem that required a bit of previous knowledge, a bit of maybe drawing a picture to set it up, then thinking about, well, how do we get what we're trying to do? Oh, add the sides and subtract, then remembering the parentheses and carrying out what we just learned. So what we just learned was a very small part of this whole problem. It was using a lot of information from the past, and you got your answer to a complicated part. All right, guys, thanks again for watching. Make sure you go through and you do your work.